We'll practice finding the fraction of mechanical energy retained after a bounce and the speeds before and after impact. Here's the problem. In a lab test of energy conservation, a ball is dropped from 2.00 meters and rebounds to 1.45 meters. Part A, find the fraction of mechanical energy retained after the bounce. Part B, find the ball's speed just before and just after impact. Part C, state where the lost energy went. First, find the fraction of mechanical energy retained. Since mechanical energy is proportional to height, the fraction is the rebound height divided by the drop height. Fraction equals rebound height over drop height, which is 1.45 over 2.00, giving 0.725 or 72.5%. Next, find the speed just before impact using conservation of energy. The speed equals the square root of 2 times g times the drop height. V equals the square root of 2 times 9.8 times 2.00, which is the square root of 39.2, giving 6.26 meters per second. Now find the speed just after impact using the rebound height. V prime equals the square root of 2 times g times the rebound height. V prime equals the square root of 2 times 9.8 times 1.45, which is the square root of 28.42, giving 5.33 meters per second. Finally, state where the lost energy went. The missing 27.5% of mechanical energy was converted to thermal energy and sound during impact. Remember that in a bounce, the fraction of mechanical energy retained equals the ratio of rebound height to drop height, and speeds can be found using conservation of energy.